designation of the letter B in NMB cable is not defined within the National Electrical Code, specifically the 2002 edition. The NEC provides standards and requirements for electrical installations, ensuring safety and proper functionality, but it doesn't typically break down the meaning of individual letters used in cable type designations. Therefore, searching the NEC for a table that explicitly explains what the B in NMB signifies will not yield any results. To understand the designation, it's crucial to consider the historical context and the manufacturing standards that were in place when these cable types were developed. The NM portion of NMB cable stands for non-metallic sheath cable. This indicates that the conductors within the cable are insulated and encased in a non-metallic outer jacket, typically made of PVC or a similar material. Non-metallic sheath cable is commonly used for residential and light commercial wiring applications where it is installed in dry locations and protected from physical damage. The B designation, however, does not have a specific definition within the NEC. Instead, this designation often refers to a specific iteration or improvement in the cable's design or manufacturing process. It is essential to consult manufacturers' specifications and historical documentation to determine the precise meaning in any specific context. Here's a more in-depth look at cable designations and where to find relevant information. Firstly, understanding cable types is essential for electrical installations. Cables are categorized based on their construction, materials, and intended use. Common cable types include NM, OFF, THHN, and many others. Each designation provides information about the cable's properties such as its insulation type, voltage rating, and suitability for wet or dry locations. Secondly, the NEC, specifically Article 334, covers non-metallic sheath cable, including NM, NMC, and NMB types. This article outlines the requirements for the use, installation, and support of these cables. However, it does not define the individual letters within the cable designations. For example, Section 334.10 describes uses permitted for an NM cable, specifying that it can be used in normally dry locations. It also specifies that NM cable cannot be embedded in plaster or concrete. Section 334.12 lists uses not permitted, such as in wet or damp locations, or where exposed to corrosive fumes or vapors. Thirdly, to find information about specific cable designations, manufacturers' catalogs and technical specifications are valuable resources. Cable manufacturers provide detailed information about their products, including the materials used, voltage ratings, and temperature ratings. These catalogs often include explanations of the cable designations and any relevant standards or certifications. For example, a manufacturer's catalog might specify that the NMB cable uses a specific type of PVC jacket that provides enhanced resistance to sunlight or chemicals. Fourthly, industry standards organizations such as the American Society for Testing and Materials, ASTM, and the Underwriters Laboratories, also play a role in defining cable standards. UL, for instance, tests and certifies cables to ensure that they meet specific safety and performance requirements. UL standards may provide additional information about cable designations and their meanings. Fifthly, the absence of a specific definition in the NEC does not diminish the importance of understanding cable designations. Electricians and electrical engineers rely on these designations to select the appropriate cable for a given application. Using the wrong type of cable can lead to safety hazards, such as electrical shock or fire. Sixthly, historical context is important when interpreting cable designations. The electrical industry has evolved over time, with new cable types and designations being introduced as technology advances. Older cable designations may no longer be in common use, but it is still important to understand their meanings when working with existing electrical systems. Seventhly, specific examples of cable designations and their meanings can be helpful. For instance, THHN stands for thermoplastic high heat resistant nylon coated. This cable type is commonly used for wiring inside conduit and is suitable for dry and damp locations. UF cable stands for underground feeder cable, which is designed for direct burial in the ground. Eighthly, it's crucial to differentiate between cable types based on their insulation and jacket materials. The insulation material determines the cable's voltage rating and temperature rating, while the jacket material provides protection against moisture, chemicals, and physical damage. Ninthly, when selecting cable for an electrical installation, always consult the NEC and local building codes. These codes provide the minimum requirements for safe and reliable electrical systems. They also specify the types of cables that are permitted for different applications. Tenthly, continuous learning and professional development are essential for electricians and electrical engineers. Staying up to date on the latest cable types, standards, and codes ensures that they can perform their work safely and effectively. 11thly, the B in NMB may indicate a specific formulation of the jacketing compound, providing better resistance to heat or abrasion than earlier NM cable types. 12thly, changes in manufacturing processes may also be indicated by the B. Perhaps a different method of applying the jacketing material or a change in the conductor stranding. 13thly, improvements in electrical performance could also be behind the B designation. For example, enhanced dielectric strength of the insulation or lower impedance characteristics. 14thly, it could denote compliance with a newer version of a UL standard. Manufacturers may update their products to meet the latest safety and performance requirements. 15thly, variations in conductor composition are sometimes indicated in cable designations. For example, a change from solid to stranded conductors or the use of a different alloy. 16thly, the B might indicate a change in the cable's overall dimensions or weight. This could be due to changes in the insulation thickness or the jacket material. 17thly, enhanced flame retardancy could be another reason for the B designation. Cables are often tested for their ability to resist the spread of fire. 18thly, increased resistance to moisture or chemicals might be indicated by the B. This is especially important in applications where the cable is exposed to harsh environments. 19thly, the B could signify a change in the cable's color coding. This is important for ensuring proper wiring and preventing errors. 20thly, cost reduction efforts could sometimes lead to changes in cable design. The B might indicate the use of a cheaper material or a more efficient manufacturing process. 21st, it's important to remember that the specific meaning of the B can vary depending on the manufacturer and the time period in which the cable was produced. Therefore, consulting the manufacturer's documentation is always the best approach. 22nd, while the NEC does not define the B in NMB, it does provide requirements for the overall performance and safety of NMB cable. These requirements include insulation resistance, voltage drop, and ampacity. 23rd, it's also important to understand the difference between NMB cable and other types of non-metallic sheath cable, such as NMC. NMC cable has a different construction and is suitable for different applications. 24th, the NEC also specifies the allowable ampacity of NMB cable based on its conductor size and temperature rating. The ampacity is the maximum amount of current that the cable can safely carry. 25th, the NEC provides tables that list the ampacity of different types of conductors. These tables are essential for selecting the appropriate cable size for a given load. For example, Table 310.15. V16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, based on the conductor's insulation type and ambient temperature. 26th, the NEC also requires that an NMB cable be properly supported and secured. This helps to prevent damage to the cable and ensures that it is installed in a safe and reliable manner. 27th, the NEC specifies the maximum spacing between cable supports. This spacing varies depending on the type of cable and the application. 28th, when installing NMB cable, it's important to avoid sharp bends or kinks. This can damage the insulation and reduce the cable's ampacity. 29th, the NEC also prohibits the use of NMB cable in certain locations, such as in hazardous locations or where exposed to physical damage. 30th, it's important to be aware of these restrictions when planning an electrical installation. 31st, in addition to the NEC, local building codes may also have requirements for NMB cable. These codes may be more stringent than the NEC, so it's important to check with the local authorities. 32nd, when in doubt, it's always best to consult with a qualified electrician or electrical engineer. They can help you select the appropriate cable for your application and ensure that it is installed in accordance with all applicable codes and standards. 33rd, the designation NMB serves as a standard for non-metallic sheath cable that has specific flame retardant properties, especially important for safety inspections. 34th, the B differentiates it from older NM cable formulations that may not meet current safety standards. This is critical when upgrading or expanding existing electrical systems. 35th, because NMB cable uses improved insulation materials, it offers enhanced protection against electrical shorts and ground faults. This is a key factor in reducing the risk of electrical fires. 36. The B designation can indirectly refer to the cable's compliance with specific UL standards related to flammability and smoke generation. These standards ensure that the cable performs safely in the event of a fire. 37th. Understanding the B helps in specifying the correct cable for residential wiring, ensuring it meets modern safety and performance expectations. This contributes to safer and more reliable home electrical systems. 38th. While the NEC focuses on insulation and safety requirements, knowing the B allows for more informed decisions about the quality and suitability of the cable. This empowers electricians to select materials that offer the best long-term performance. 39th. Checking the manufacturer's datasheet provides insights into the specific improvements represented by the B, such as higher temperature ratings or enhanced chemical resistance. This allows for precise matching of cable characteristics to the demands of the environment. 40th. The NMB cable, thanks to the B designation, generally offers better durability and longevity compared to earlier NM cable types, resulting in fewer maintenance issues. This reduces the overall cost of ownership and increases customer satisfaction. 41st. When inspecting existing electrical systems, the presence of NMB cable provides assurance that the wiring meets more recent safety standards, reducing potential liabilities. This helps property owners feel confident about the safety of their electrical infrastructure. 42nd. NMB cable is typically easier to work with due to improvements in the flexibility and handling of the cable, making installations quicker and more efficient. This saves time and reduces labor costs. 43rd. The B in NMB indirectly signifies that the cable has undergone more rigorous testing and certification processes, offering enhanced reliability. This gives electricians and homeowners peace of mind. 44th. Even though the NEC doesn't define the B, manufacturers often include this information in their product literature, which is a key resource for understanding the cable's features. This ensures informed decision-making and proper application. 45th. NMB cable can be differentiated more easily, ensuring that the correct type of cable is being installed in accordance with current regulations and best practices. This reduces the risk of errors and code violations. 46. The B in NMB signifies that the cable has been designed to be compatible with modern electrical devices and systems. This makes integration smoother and more reliable. 47th. The improved performance of NMB cable, as suggested by the B, can lead to energy savings by reducing voltage drop and improving overall system efficiency. This translates into lower electricity bills and a smaller carbon footprint. 48th. NMB cable tends to be more resistant to environmental factors such as UV radiation, ozone, and temperature fluctuations. This extends the lifespan of the cable and reduces the need for replacements. 49th. The enhanced safety features associated with the B and NMB cable contribute to lower insurance premiums for homeowners because it reduces the risk of electrical fires. This provides a tangible financial benefit. 50th. The B indirectly represents a continuous improvement in cable technology, leading to safer, more efficient, and more reliable electrical installations. This fosters trust and confidence in the electrical industry.